All right, so today we're doing a deep dive into material stress analysts. We've got some really interesting info from RoleCatcher.com. And, I was thinking about this earlier. Like, you ever think about how something like a prosthetic leg actually gets made?
Yeah, it's pretty incredible, isn't it?
It's not magic, right? There's got to be some serious science behind.
Oh, absolutely. It's definitely not magic. There's a ton of science and engineering that goes into it, and material stress analysts are essential to that whole process.
Right, because we can't just, slap some metal and plastic together and hope for the best. So are these analysts kind of like material detectives? At least that's the impression I got from RoleCatcher.
Haha. I like that analogy. They really do play a detective role. They use all this specialized software, almost like high-tech magnifying glasses, to see how different materials will behave under stress.
So we're not just talking about like a chair holding someone's weight here.
No, not at all. This applies to everything. From that chair you mentioned to a plane wing enduring crazy speeds and pressure.
Wow, okay, so the stakes can get pretty high. So it's not just about making sure things don't break right. It's about figuring out exactly how much stress something can handle before it even gets close to that breaking point.
You got it. They actually run simulations. It's like putting a virtual car through a crash test. But instead of the whole car, they're looking at how individual materials in the frame would react.
At like a molecular level.
Exactly. They use something called finite element analysis, which basically breaks the material down into tiny little pieces. And that's how they can see where the stress concentrates.
And where those potential weak points are.
Exactly.
That's wild. Okay, so RoleCatcher also mentioned something about different types of analysis.
Oh yeah, there are a few.
There's one for things that move right, not just stuff that stays put.
You're thinking of dynamic analysis.
Right, dynamic analysis.
So you've got static analysis for loads that don't change, like a building just standing there.
Right, makes sense.
But dynamic analysis, that's for all the things that move and vibrate. A car on a bumpy road, an airplane wing during flight, that kind of thing.
Okay, got it. So
Yeah.
they're analyzing how those forces impact the material over time.
Exactly.
So that's two types down. What was
Yep.
the third one again?
Ah, yes, fatigue analysis.
All right, fatigue.
That one's all about how materials weaken over time, even with relatively small stresses.
Okay, so like bending a paperclip back and forth until it
A
breaks.
perfect example. You're not using a ton of force each time, but eventually it gives out. That's fatigue.
And for things like airplanes or bridges,
Mhm.
I'm guessing understanding that is super important.
Absolutely crucial for safety.
Wow. This is way more detail than I ever imagined.
It's a lot more than just, yep, this material seems strong enough.
Right. There's a lot riding on their analysis.
Absolutely. They're responsible for making sure those materials can withstand whatever demands are placed on them, whether it's a one-time load or repeated stresses over years of use.
So their work is kind of like the invisible backbone of so many things we rely on.
That's a great way to put it.
And you know what else I found interesting in the RoleCatcher research? They kept mentioning communication and teamwork skills, which honestly, for a job that seems so focused on numbers and software, kind of surprised me.
Yeah, I can see why you'd think that.
So is that actually a big part of the job?
Oh, absolutely. Those soft skills are crucial in this field.
Really? Okay, I got to ask why. Why are those skills so important if you're already the expert on how materials behave?
Because it's not enough to just have the answers you have to be able to explain them.
Right, like you can't just be a brilliant scientist who mumbles to themselves in a corner.
Exactly. You need to be able to communicate your findings to people who might not be as technically minded. Imagine you're presenting to a room full of executives. They need to understand your analysis to make informed decisions.
Okay, yeah, that would require some serious communication chops. Especially if you need to convince them to, say, invest in a pricier material or change a design based on your recommendations.
Exactly. It's about taking those complex technical details and translating them into something everyone can understand. And it's not just presentations either. Think about the reports they write. Those reports might be the only insight other teams have into the potential strengths and weaknesses of a design.
Oh, wow, yeah, that's a lot of pressure. They're basically responsible for communicating potentially critical information in a way that everyone gets it and can actually act on.
Absolutely. And that's where the teamwork aspect comes in too. Remember, material stress analysis isn't done in a vacuum. They're constantly working with other engineers, designers, even the manufacturers.
So it's more like a collaborative investigation then, rather than one person calling all the shots.
Precisely. Think of it like a team of detectives trying to solve a case.
I like that analogy.
The material stress analyst brings their expertise on materials to the table, but they're just one piece of the puzzle.
So they might point out a potential design flaw or suggest different materials that could improve performance.
Exactly. They're there to offer those insights and work together to find the best solution. Maybe it's a small tweak to the shape of a part to distribute the stress more effectively, or they might recommend a surface treatment that could improve the fatigue life.
It's about using their knowledge to help the whole team make the smartest decisions.
Exactly.
This is really giving me a new appreciation for how collaborative engineering really is. It's not just about lone geniuses in their labs. It's about these teams of specialists all working together.
That's a great way to put it. And as we dig deeper into the career path of a material stress analyst, you'll see how that collaborative spirit becomes even more crucial, especially as they move into those more senior roles and take on bigger responsibilities.
It's funny how we always picture engineers as these lone figures hunched over equations, but it sounds like teamwork is a huge part of material stress analysis.
It really is, especially when you consider how much this field is always changing.
Right, and speaking of that, RoleCatcher had some really interesting profiles that showed the career progression of a material stress analyst.
Yeah, they're a great resource for getting a feel for what that journey looks like.
One thing that really jumped out at me was the emphasis on staying ahead of the curve.
Oh, absolutely.
It seems like the learning never really stops for these folks.
It makes sense when you think about it. New materials are being developed all the time. Software is getting more sophisticated. Even the techniques for analyzing stress and strain are constantly evolving.
So how do they actually stay up to date? Are there like material stress analyst conferences or something?
You laugh. But yeah, conferences are actually a big part of it. It's a chance to hear about cutting-edge research, network with other professionals, bounce ideas around, and of course there are journals, online courses, workshops. There's a whole world out there dedicated to keeping material stress analysts at the top of their game.
Wow, it's like they have to be comfortable with being lifelong learners,
Pretty much.
always adapting to new discoveries, new tools.
Exactly. And that's what makes it such a dynamic and exciting field.
Right, because that constant evolution opens up so many possibilities.
Think about like the development of those super strong, lightweight composites they use in aerospace now.
Oh yeah, good example.
Or how 3D printing is changing the way we design and manufacture just about everything.
Material stress analysts are at the forefront of all that.
Exactly. It's not just about preventing disasters, it's about making those breakthroughs possible.
It's like they're the unsung heroes of all these cool innovations we see.
I like that. Unsung heroes.
Well, it's true. We might not see them, but their work is impacting so many aspects of our lives.
And it's not just the big headline-grabbing stuff either. Think about the safety features in your car,
Right.
the durability of that prosthetic leg we talked about. All of that goes back to material stress analysis.
It's really making me appreciate those everyday things in a whole new way.
It's about making sure those everyday things are safe, efficient, and built to last.
Absolutely. And I think that's a great note to end on. So in a world that's constantly pushing the limits of what's possible, material stress analysis is key. It's not just about preventing failure. It's about enabling innovation. It's about making sure we can dream big and actually build those dreams.
Well said. Couldn't have put it better myself.
It's been fascinating learning about this often invisible profession. And on that note, we'll leave you with this. Think about the objects you use every day. Your phone, the chair you're sitting on, even the bridges you drive over. Behind each one is a material stress analyst working to make sure it can handle whatever life throws at it. And that is a pretty cool thought to end on.